Welcome to a Finite Math podcast. In a previous episode, we found the mean of a distribution of salaries of university presidents that you see here. Well, it's been modified a little bit. I decided that there were too many zeros there, so I restated everything in thousands, so that we found that the average or the mean salary of these 162 presidents was 409,000. That just appears a little to the right of this division of the categories here. Now, what we want to do in this episode is we'd like to measure how spread out this data is. In other words, we'd like to find a way to measure the variability of the data. All right, so we'll do this to a clean sheet here. Okay, here is the calculations we have. Now, what I would like to do here, when we go and measure the variability, we want to see how far each of the data points, in this case the midpoints, is located from the mean. So we want to take that difference, and we want to basically average that difference. Now, the problem is that some of the midpoints are above the mean and some are below, and so if we just average them, the positive numbers will cancel with the negative numbers, so we square them instead. So here we see a template here that will be just like we did when we were doing an average, except we're going to average now the square of the differences between the data points, the midpoints, and the mean. All right, let's do the calculations. Find those frequencies. Look at the midpoints. And now the mean down here, I want to make sure, since I copied, the thing doesn't change, so I'll make it an absolute constant by pressing the F4 function key, and then, of course, square it here. All right, now I can copy that down by using the fill handle. Now, to calculate the average of these differences squared, we first of all need to come up with the sum. So we'll add our squares of differences there. And now the variance is just going to be this average. So we'll take the sums that we calculated and divide by the total number of data points. Now, in doing that, I'm sort of assuming we have an entire population. The formula says that if we have a sample, we should divide by one less, in other words, 181. Well, dividing by 181 and 182 is not going to be very significant here. Now, we squared when we were measuring the differences, so we have to unsquare. So we do that with the square root function SQRT, and we see if we can put a number in there, and it gives us the square root of that number. And so we see that the standard deviation comes out at 137. Now, there are various interpretations for this. For example, if we take the mean and subtract 137, that gives us about 270. And if we take the mean and add 137, well, that's going to give about 546, something like that. Then if we look at our histogram, what that tells us is that if we look between those two numbers, between 270 and 546, that should capture about 68% of the values that we have here. And we see roughly that looks like it would be the case. Well, thanks for stopping by. Look forward to seeing you again.